The purpose of this video is to show how to pivot a data set in Python, much like you might do it in Excel, only it's easier here, and then how to use correlation and heat maps. So we're going to start by looking at this data set, which is a CSV file. It has returns on a stock, returns on a market for different companies, and they're stacked one on top of each other, which isn't very useful for analysis. But this is how it comes from the database that we use. So this will tell you that, hey, we can sometimes get data that isn't in the form that we need it. So we need to change the form of this data. So the way we're going to do that is to use Python. So I'm going to start a new program. And I'm going to import what I need to import. And there's quite a number of things to import. So I'm going to do a bunch of typing here. And I don't know if you want to follow along with the typing, but I'm going to talk while I do this. Import pandas as PD. So anytime we use PD, we're referring to pandas. Now pandas is how you manage the data. Basically a data frame. A data frame, you can think of imagining a big table. And this table can have 2 dimensions, 3 dimensions, whatever, but it's a data frame that's going to contain our data. And pandas are useful for manipulating data frames. We're also going to use NumPy, which is very good for creating arrays and doing various calculations. So we always seem to add NumPys whether we need it or not. We're going to import date time as dr. And that'll help us work with dates. Dates come from different databases in different forms, and Python tries to figure out what form that date is in. So if you're feeding in data from SAS or Stata or Excel, the dates have different bases for their serial numbers. And so what's handy about Python is it can figure it out. So I'm going to also add statistics so we can do some correlation. I'm going to import matplot so we can do some graphing. And from, which means part of the matplot library, we're going to add a part of it, and that deals with styles. Because you'll find that after you get good at using matplot, you might want to use some styles. And this is similar to what you might have in styles in, say, Excel, and different styles of graphs and so forth. Now we need pandas data reader. And what this allows us to do is read different forms of the data. We're going to read CSV, but you could read Excel and many other forms. And then we're going to have something to do with Seaborn, which helps us a bit with the graphing that we're going to be doing. And we're going to choose a style. Now you don't have to use a style, but I'm going to choose a style just so you can see how one is used. And you can Google Seaborn styles to find the style that you like. I'm just going to choose one there. Alright, so we've done all the importing we need to do, set up the libraries. And if any of these have not been installed on your computer, you need to do the pip install. And that's going to your command prompt and then doing a pip install for whatever you don't already have listed here. So now what we're going to do is we're going to actually create a data frame. And the common name used for data frames is surprise, DF. And what we're going to do is we're going to read in the data, and it's in CSV form, so we're going to use the panda read underscore CSV. And now what we're going to do is tell it what this data file is called, stock returns CSV, and you have to be very precise with this. Make sure it matches your file name exactly. If it doesn't, it's not going to read it. Parse dates equal true. And what it's going to do is it's going to look at the dates that are coming in, and say, okay, now what form is it in? And it's going to guess at which the best form, because the dates are coming in this particular database as a year, month, day format. And index column equal 1. Now counting in Python starts with 0. So when visually this would be the second column, or column B in your data set. But we're referring to as column 1, that we're going to use that for our index. And that particular column corresponds to the dates. And so we'll be using the dates because ultimately we want to line up all the stock returns by date. Because right now everything is in a very long list with the dates repeated for every company stock. So what we're going to do is change that around. Now what we can do is see what we've already read in by looking at the header for the data frame. So what we do is we say print DF, meaning their data frame, which is the one on the line above. Head means the first 5 observations. We're going to run this, but we're going to have to name it. Well, it's going to ask us to name it, which is fine. We're going to save it as, and I'm going to save it in my Python directory, and I'm going to call it demo core. Now it's going to run it, and it's giving me the header. So the header for that data frame is the first 5 lines of that CSV file. And that's what we expected. That's good news. Now we're going to pivot. And we're going to pivot on the tickers that we have in here. So we're going to create a new data frame, call it DF2. Not very original, but that's customary to do that. PD dot. Now we do pivot table. We're going to pivot the data frame called DF. We're going to pivot using an index of the date column, and the reason why I know that is I looked at the CSV file and the column heading is date with a lowercase d. You have to be very precise here. If date had uppercase D, I'd have to put that in here. But this is exactly how it is in the CSV file. Columns equal, and now I'm going to put the name of the column that I want to pivot on, ticker, and it's all uppercase because that's how it is in the CSV file. And the values that I want to use are in the column called RET. Now what I want to do, once I pivot the data, I want to see what it looks like. So I'm again going to print the header, print, but now the header of DF2. And I'm also going to print DF2 dot describe. Now this will give me a little information on each of them. So I'm going to do is go ahead and run this. Okay. And I spelled something wrong, so I go back and fix it. It should be values equal. So we run it again. And you can see how the error messages are coming up in red. No problem. Errors happen. Now if you look at what's happening here, we've got the header for DF. Now we have the header for DF2, which is the pivoted data, and then we have the descriptive statistics on each of the new columns. So we went from column headings, for example, the date and the returns and ticker, and we pivoted, so now we have all the returns for Amazon, Ford, GE, and so forth laid out, all matched by date, which makes it a lot easier to do this. Now let's say that we have a use for this file. That is, we want to have the pivoted data printed out somewhere. So what we can do is create a new file, df2 underscore CSV, and make it a new name, new stock returns. And I want this to be a CSV file, so I'm going to CSV for the extension. So now when I run this, it'll actually take the pivoted data, which is in DF2, and write it to a new spreadsheet. And then I can go on my merry way if that's all I wanted to do. What I'm also going to do here is look at the column headings that I have. So a way to do that is for col in F2 columns. And you'll notice that I hit enter and it automatically indented a bit. And you're going to find that happening quite a bit. Most of the time with these types of things, what you want to do is you indent 4. 4 seems to be the magical number for indenting. But let's see if this works. Print call. So call is a made-up name, and what it's doing is putting the column heading. So let's see if this works. I'm going to run. And there are column headings. AMZN, F, GE, GIS, and so forth. So that's what this command did for us. Now, all we're left to do here is do some correlation. So I'm going to make up a name. I'll call it CORR. It's a made-up name. Equal df2.core. And that'll create the correlation matrix and store it in CORR. So when you have the storage on the left-hand side of this equation, it's not storing it as a single number. It's actually storing a bunch of numbers. So we can then print core and see what that looks like. So now I'll run it again. And there's our correlation matrix down here at the bottom here. So those are just the Pearson correlations. Now what we're going to do, and the next thing and the last thing we're going to do is we're going to create a heat map of the correlation. Now the typing is very fussy here, so a typo is not unexpected. So what I'm going to do is use the Seaborn, so SNS, because that's what's above when it says import Seaborn as SNS. And now I'm going to do a heat map. And I'm going to do it of the correlations that we just did, which are stored in the variable core. And I want some information here. Now what I'm doing here is I'm saying, look, in this heat map, I want to know which variables are which and which are correlated with which. So I'm going to put the labels on the x-axis and the y, and you'll see these when we do actually produce this. Tick labels, I have to make sure to spell labels correctly, equal core dot columns. And I'm going to hit enter so everything's on one page so you can see it without scrolling. ANNOT is for annotation equals true, meaning I want to see not only the color, which is the degree of correlation, but I also want to see the actual correlation numbers. And then CMap would be my color scheme, and I'm going to do blues. There are different color schemes, and I'm just going to do blues. So my heat map will be in different shades of blue. Now nothing's going to show unless I do plot show. And so I'm going ahead and run this, and hopefully I don't have any typos. Everything looks good so far. And there's my heat map. And you can see this heat map is going to represent, you're going to see these are the X tick labels and the Y tick labels are produced here, which are the column headings. And we said annotate true, which means we actually get the correlation in here. So in addition to the heat map, which is the different gradations of the blue coloring to indicate the degree of correlation, we also get the actual correlation in here. All right. Thank you.